Hi, welcome to a class on ethical considerations in machine learning. That AI will have a major impact on society is no longer in question. Current debate turns instead on how far this impact will be positive or negative, for whom, in which ways, in which places, and on what time scale. Now let's see what machine learning is. Machine learning, ML, is a powerful technology, whose application to the web promises to bring benefits and enable compelling new user experiences. But there is also increasing awareness that ML applications can create harms, intentional. Now let's discuss about general ethical issues in machine learning. As well as potential benefits, there is increasing awareness that the application of machine learning poses risks and can lead to harms, raising a range of ethical questions. This section presents a brief overview of some key concerns.
The accuracy of an ML model is the proportion of examples for which it generates a correct output. Leslie. In general, high accuracy is a good thing, and low accuracy can lead to harms, for example where facial recognition systems are used in law enforcement. But highly accurate facial recognition systems can also pose risks to privacy and autonomy, for example mass surveillance.
In some areas such as credit scoring or loan approval, increasing the accuracy of predictions might come at the cost of requiring access to too much personal data. There is also concern about the overhyping of the ability of AI to accurately predict certain things at all, particularly social outcomes such as job performance or criminal recidivism. Accuracy may be a useful measure where an area has a clear, objective ground truth, for example vehicle license plate recognition, but many areas of human judgment are nuanced, messy and contextual, and simple accuracy risks being too reductive a measure. An incorrect output produced by an ML model can have varying context-dependent impact. Leslie. For example, when identifying cancerous skin growth, false positives may increase the cost of cancer detection, by requiring additional lab work to rule them out, while false negatives may delay treatment to the point where it is no longer effective. What matters here is lowering the risk of false negatives. In a judicial context, false positives may send innocents behind bars, while false negatives might make it more difficult to convict a criminal. What matters here is lowering the risk of false positives.
Bias has a number of meanings, including a systematic deviation from a true value. This can be positive or negative. Bias is a prominent concern in ML ethics, where the concern more specifically is a systematic skew in decision-making that results in unfair outcomes. Concerns about bias are particularly prominent where negative outcomes, such as inaccurate predictions and their consequences, disproportionately affect individuals or groups who are vulnerable or historically marginalized. Where the unfair treatment relates to protected characteristics such as race, gender, disability or sexuality, bias can constitute illegal discrimination, depending on relevant laws.
There is no single definition of fairness. Mirabi also has a good survey of definitions. Like ethics, it is contextual and varies according to different values, perspectives and societies. But one core idea is that people should be treated equally unless there is a justified, relevant reason not to. Fairness is often a lens through which to make sense of other ethical concerns. As noted above, bias can be positive or negative. It's when it leads to unfair outcomes that it is problematic. Where ethical principles or concerns need to be balanced against each other, considering fairness often provides a guide to how to do that.